While most kids are currently out for their holiday break, it's time for me to go back to school. You folks may already know all this that I still have to learn, but if not, maybe you'll get something out of my sometimes comical efforts to improve. If you've watched much of my content, you'll know that my diagnostic skills are, shall we say, somewhat lacking. I do my best, but I have a long way to go if I ever want to get anywhere beyond the enthusiastic amateur stage. In this case, I'm also working with a computer, the Apple II Plus, about which I have very little knowledge. I know the absolute basics of how a computer operates, but shockingly little about how this one works. I'm also going to be touching on switch mode power supplies here, and I barely even know anything about linear supplies. So, if watching an inexperienced hack make a complete fool of himself appeals to you, or if you're genuinely interested in the subject matter and want someone to learn with, grab yourself a beverage and a snack and sit back while I try to delve into the mysteries of the Apple II Plus and see if I can get any signs of life out of the old girl. We left off last time with the 2 Plus case, main logic board, and peripheral cards all having been for a clean. They're now well dried and ready to move on. Next, we opened up the power supply and replaced the one and only Rifa branded cap, and I also took a look over the power supply board to see if there were any obvious signs of damage, which I didn't find. And finally, I also examined what I imagine will be the toughest keyboard I've ever tried to revive, with all those delicate little leaf springs that have to go together just so. I'm not looking forward to that part of this repair. In preparing for this video, I retested the power supply and got some unexpected results. Without connecting it to the main logic board, I was able to start the supply and read all 4 voltage rails, plus and minus 5 and plus and minus 12. That alone surprised me a bit, as I had been led to believe that these old switching supplies often needed a load on one of the rails just to get regulated properly. The rails were reading a little high, but as I understand it, that's normal. The next thing I did was probably a bit stupid, but a bit stupid is kind of my brand. So, I connected the power supply to the main logic board. I didn't think it was too risky because I'd been doing a little research on the Apple II power supply. It's the same basic design between the 2 Plus, and the 2E, and I found that it does have overvoltage protection in the form of a crowbar circuit. We'll certainly be talking more about that later. If the main logic board were shorted, the overvoltage protection should cut off power and save components on the main board from going all crispy. So I switched on the power supply and probed voltages on slot 0. All 4 voltage rails appear on all the peripheral card slots, so they're an easy place to look. What I got, however, was fluctuating voltages. I could also hear a faint ticking or clicking sound coming from the PSU. From some research I'd done, I believed that to be the power supply attempting repeatedly to start up. That also made sense with the fluctuating voltages. My first thought was that there was a short on the main logic board causing overvoltage and triggering the crowbar circuit, so I disconnected the power supply from the main board and checked for shorts on all 4 voltage rails by testing continuity on the power connector between ground and each voltage pin. I didn't detect any dead shorts, so I switched to resistance mode on the multimeter and measured the resistance on each rail. 3 of them were in the kiloohm or megohm range, and the negative 12 volt rail read a few hundred ohms, but that shouldn't be enough to qualify as a short. Okay, so what's going on? At that point, I still didn't know whether the problem was with the main logic board or the PSU. I think, and feel free to either confirm this or correct me in the comments, that it's possible for a short to only appear when current is applied to a circuit, so the main board could still be to blame. Alternately, the fault could lie in the power supply, and that seemed easiest to check, so that's where I went next. I reopened the power supply and examined it to see if I could find anything I'd missed. I still saw no leaking capacitors, burned components, or cold or broken solder joints. So the next thing to check was the little 220 microfarad startup capacitor. It sits on the board right next to a high wattage resistor that gets very hot and can cook and dry out that little capacitor. So I pulled it from the board and tested it. My cheap little component tester showed it at about 235 microfarads with an ESR of less than 0.7 ohms, so that looked good. Just to be on the safe side though, I went ahead and replaced it. The original cap was a 220 microfarad 10 volt 85 degree capacitor. The closest I had in stock was a 220 microfarad 16 volt 105 degree cap, but that should be perfectly fine. You can replace a cap with a higher voltage but not lower, and this one had a higher temperature tolerance. No change. While testing the power supply with the new cap, I started hearing a crackling or staticky sound when switching the power supply on and off. I tracked that sound down to the power switch. On testing the switch, I found one of the poles was making only intermittent contact. If you wiggled the post, which was very loose, while testing continuity, it would come and go. So I replaced the switch. Fortunately, I had a new one in stock that was almost a perfect fit. I just had to file 1 or 2 millimeters off one end of the opening, and you can't even see it once the switch is fitted in place. Still no joy. The problem could still be the power supply, though. I didn't see any leaking or bulging capacitors, but that doesn't mean they're all good. Remember, these things are over 40 years old, and while capacitors from that period have a good reputation for reliability, there are always exceptions to the rule. I'd have to pull each capacitor and test it to be sure, but I don't want to do that until I confirm that the problem is in the power supply and not on the main logic board. There could also be a problem with the crowbar circuit, making it sense over voltage and shut down the power supply even when there isn't an actual problem. The crowbar circuit consists of a couple of resistors, a Zener or Zener diode, and a thyristor. When the voltage reaches the breakdown threshold for the Zener, it begins conducting in reverse, shunting excess voltage to ground and to the gate of the thyristor. The voltage on the gate of the thyristor causes it to open and allow current to flow between the plus 12 volt rail and ground. Now here's where my understanding of the switch mode power supply breaks down pretty badly. I believe shorting the 12 volt rail switches off the regulation feedback circuit by basically turning off the LED in the optocoupler, causing the power supply to reset. I'm sure you all will help me understand that better with the comments below. All that being said, I believe if the Zener diode or the thyristor have deteriorated, that could cause the power supply to continually reset when under load. So that brings us up to today. And I still don't know if the problem is in the power supply or the main logic board, and I have to figure that out before I can go any further. Fortunately, there is something I can do about that. I can replace the power supply with a known good one. If I get good voltages on the main board at that point, I know the problem is in the power supply. If I still don't get correct voltages with the good PSU, I know the problem is on the main board. Either way, I'll have narrowed down the location of the fault and can continue troubleshooting from there. So what I am going to use is this. This is a Pico RC power supply that's designed for the Apple II series. The Apple II, the II Plus, and the IIe. Has the right power jack with the right rails on it, plus and minus 5, plus and minus 12. And to get its power, it uses a Pico ATX power supply with a 24-pin connector. This is designed to be a drop-in replacement for the power supply in the Apple II series. It mounts into the case in the same position as the original power supply and screws to the base with these two standoffs. And it just uses a 12-volt DC wall wart for power through this barrel jack. So I'm going to move this power supply out of the way, and we're going to get this power supply installed. What we're going to be looking for is to see if the power rails hold with this power supply. If they do, then we know the power supply is bad. If they don't, then we know the issue is on the main board. There's our 12 volts, and you can see we have a power light on the Pico ATX power supply. Now this came as a kit, just to be clear. It came as a kit. I showed it before on the earlier video. It was still in this bag, and I have since assembled it and gotten it ready for this. So now we're going to bring up the multimeter, and we're going to be testing our voltages on the peripheral card slots. All 4 voltage rails appear on these slots. We have ground. I don't know the pin. I don't remember the pin numbering, but we have ground here. +5, I believe, is here. +12 is here. And then it says 26, 27, 28, 29, 30, 31, 32, 33, and 34 are the 2 negative voltage rails. So that's where we're going to look for our power. So let me power this up, and let's see what we're getting. Oh, I have to switch into voltage mode. All right, what are we getting here? Well, that's our 12 volts, plus 12. This will be our +5 then. There it is, +5. I'm not making good contact with the pins. 6, 27, 28, 9, 30, 31, 32, 33. That is our -12. And that is our -5. So we have all 4 voltage rails, and they look stable. So we now know that the problem we had is actually with the power supply. We'll go ahead and work on the power supply later, but for now we're going to continue checking the main board. And to do that, the first thing I'm going to do is plug in the speaker and see if we get a beep. If this thing is working at all, we should get a beep out of the speaker when I turn it on. Here we go. Okay, that's a positive sign. So we'll push it off again, and now we'll give it video. This, so you can see the output. Now this is hooked up composite video through the RetroTink. So let's see if we get anything here. Cross your fingers. And there we go. We have a working Apple II mainboard, or at least a mostly working or partially working Apple II mainboard. All right. The next thing we can do is we can run this thing through some diagnostics, or at least theoretically. Adrian Black and IZ8DWF, and I think one other fellow, not too long ago, they put together a dead test diagnostic ROM for the Apple II series. And that ROM goes into the F800 ROM slot. Now, the trick is these aren't standard like 2316. These are 2K ROMs, but they're not like 2316s. They're 9316s, and that gives them a slightly different pinout. In addition, the way that the Apple II works, the ROMs can be bypassed with a signal called inhibit, which is active low. And there are 3 chip select lines on these, and one of them is tied to that inhibit. So for a proper ROM replacement, if you want to use something like a 27C256, which is what I've got in here with that diagnostic ROM programmed onto it, you need to swap some signals around. And the way I did it, and I designed this little board. I sketched it up on paper here and then wired it up on a proto board. The way I did it, that inhibit signal is active low, and the chip select that I tied it, or not the chip select, the output enable that I tied it to on here is also active low. So since that's an inhibit, it's really the reverse of what it should be. So if your inhibit is active, so active low, then you want the chip select not to be selected. So I had to invert that signal, and that's what we've got here. This is a 7404 hex inverter chip to reverse that signal. Now, I have not had an opportunity to test this little board because I haven't had a working Apple II to plug it into. So this may or may not work. I hope I wired it up correctly, but we'll find out. Okay, now you have to be careful with this. Everything on this board that I can tell, pin 1 faces toward me, toward the keyboard connector. So this board is actually designed for that. The EEPROM and the 7404 are both aligned the same way. Okay. So in theory, if I built this board right and I start this up, we should get a Mr. Black's diagnostic ROM. Okay, according to the instructions on Adrian's GitHub page, I think there's still a problem somewhere. Upon powering up the machine, it'll beep the speaker to indicate things are working. The ROM will test the 0 page and stack using a MarchU test, one of the best RAM tests available. This will catch page errors within the 0 and stack pages, and if any issues are detected, it'll beep out an error code to indicate which bit is bad. Next, the ROM will do a quick test for page errors inside the RAM. This is a subtle issue that can fool many RAM tests. For main RAM test to run, we need fully functional 0 page and stack. And if these will get corrupted by a page error causing the ROM to crash. The page error test tries to prevent that from happening. The page error test works by writing hex 00 to address 0000 inside the 0 page, and then writing FF to hex 100, 200, 400, 800, hex 1000, hex 2000, hex 4000, and hex 8000. If, when writing FF to those locations, the 00 at location 0000 is disturbed, then we have a page error and must halt. There's a bit more going on, but it's not relevant. If the page error test fails, the ROM will beep out which RAM bit is bad, helping indicate which chip has a page fault. In the event that location 00 is corrupted with the value of FF, this indicates a logic problem on the motherboard. So that didn't happen. The next phase is to detect how much RAM is installed in the Apple II. Valid configurations of the Apple II are 4K, 8K, 12K, 16K, 20K, 24K, 32K, 36K, and 48K. Currently, this test does not test above 48K because using and testing that RAM requires banking out the ROM. The ROM will print a banner showing how much RAM is detected and that the 0 page and stack page are good. It will then proceed to do a MarchU RAM test on all the RAM. So where I see a problem is when I start this up, like so, we get the double beep, that's fine. But then I think this is supposed to be that banner page, and it doesn't show correctly. And then it starts the MarchU test on the main RAM. So something is wrong somewhere in either the video circuitry. I don't think it's the video circuitry because this is working correctly. Of course, this is in graphics mode or semi-graphics mode. When it gets to the end of this, it's also supposed to show a results page. And that was also corrupted. So although I think the RAM is fine, there's a problem somewhere else on the board. This, I think, is where it should be telling me what's good and what's bad. And I just get a screen full of ampersands. So there is something going on with this main board, but I'm not sure what at this point. I'm not sure exactly what the symptom is. So, all right. That being said, we know where we stand. We have a problem with the power supply. We have the keyboard to redo, and now we have an identifiable problem on the main board, or at least a problem that we can try to track down. Just checking for any particularly hot chips. Nothing's particularly hot. The CPU is warm-ish. I'm going to try one thing. I don't think this will be the issue, but it could be. I'm going to try another CPU. Here's a MOS 6502 AD from the 24th week of 88. Let's see what that does in here. Still with the diagnostic ROM. Well, it's running the diagnostic. Still get the garbled screen though. Okay, so the CPU doesn't seem to be the issue. At least we can say that. That restart was the power supply has a slightly wonky barrel jack. Doesn't always make good connections, so when I was fiddling with it, it powered off and powered back on. So here's the original CPU back. It would be back in if I had lined it up right. Okay, the original CPU is back. There we go. There we go. All right. So now we're going to go ahead and look at the power supply and see if we can get that working again. Before we do, I will mention that I have reached out to Adrian Black to see if he can provide any insight as to what his and Frank's and the other gentleman, I can't remember his name, I'm sorry, but what their dead test diagnostic is doing and why it's not providing me the splash screen and the results screen. Of course, Adrian's a busy man, so I don't expect a result or a response anytime soon, but hopefully he will get back to me and maybe give me some direction on that. So as I said, in the meantime, we're going to go ahead and take a look at the power supply. Now, I have gone ahead and pulled the power supply out of its case again. I've also got a capacitor kit for this specific power supply from Console 5. And this power supply, just FYI, there are several power supplies that can be used in the Apple IIs. This one is the Aztec A11040, and I do have schematics for this specific supply, and I have parts lists. So I do know that what the specification for the Zener diode is. I know what the specifications are for the caps, but of course, Console 5 gives you the specific caps that you need. They also supplied me with a replacement for the REFA. Of course, I've already done that, so I won't be putting that one in. I have already, as I mentioned, replaced the little startup cap, the 220 microfarad, but I replaced it with a 16 volt, and the original was a 10 volt, so I will probably put the one in that came with the Console 5 kit. I also do have a kit of thyristors. However, I don't know which one would be the right one to replace the one in this power supply. I can't find the specifications on this one to know which one to replace it with, so I may not be able to do that if that's the problem. I'd have to do more research to try to figure out what the specs are and get it replaced with a correct matching part. So what we're going to do today is we're going to go ahead and replace the Zener diode, and I'm going to recap this. Now, I am aware that there is a good deal of controversy on the issue of recapping. And the truth of the matter is, as I've said before, none of these caps look like they're bulging. I can't see any indication of leakage. However, since we are having a problem with this power supply, I am going to go ahead and do the recap. As I do it, I'm going to test each of the caps that I pull out. All I've got, of course, is this little cheap component tester. It gives you an idea of whether a capacitor is in spec, but it's not perfect by any means. I'm not sure there is a perfect means to test caps, but this will give us an idea at least if any of them are showing bad. So for those of you of sensitive disposition who don't like recapping, you may want to turn away at this point because I am going to pull all these caps and put new ones in. So let's get started. I am going to start with the Zener diode down here. This Zener is a 12.2 volt plus or minus 2, and I have here 12 volt Zener diodes. So I'm going to replace the one in the board with one of these. We have our Moo gun, as Lee from More Fun Making It calls it, or desoldering iron, desoldering gun. And we're going to go ahead and see if we can get this out of here. This is a single-sided board, so it shouldn't be that difficult to do these desolderings. Parts should just come out. Grab a pair of tweezers to help me get this out of here. And that just came right out. Now that Zener diode may be good, I don't know. But it's at this point best to play it safe and go ahead and replace it. Okay, here's the Zener replaced. We can test that later. We have to run voltage through it to make sure it's got the right breakdown voltage, but we could do that. So that's the Zener. Now I need to start with the capacitors. And I think we will start on the low side. So that's going to be these 5, these 2, and these 2. Because these have thicker legs, I'm going to start with braid. Let's see if I can clear some of this, and then we'll go to the Moo gun as needed. Plus the legs are bent over, which makes it hard to use the Moo gun. We'll add a little flux to see if we can make this easier. We'll also ramp up our temperature a bit. I was at 320, I'm going to go up to 350. Apologize, but I am actually also going to start the extractor fan. Marking on the board says positive is toward my left, so, and that matches with the way the capacitor was mounted. So this is a 1000 microfarad 10 volt, and that's going to be, I believe, one of these. See that? Focus, there we go. 1000 microfarad 10 volt capacitor. So we're going to go ahead and put that one in place. We'll do these one at a time so as not to get them mixed up. Go ahead real quick and take a look at that capacitor we just pulled out. Where did it go? Remember, this is a 1000 microfarad capacitor. And we get 1709 microfarads. So that's a little out of spec. The ESR is not 0.43, so that's good, but 1700 instead of 1000, that's not right. Again, I can't 100% trust that little tester, but hey. So I'm going to go ahead and do these, and I will stop and talk if there's anything notable. Otherwise, I'm just going to fast forward through this until something interesting happens. That was the third capacitor that has read significantly high compared to its specification. That was another 1000 microfarad that was reading at 1700. So I'm testing one of the brand new caps. I've already done this earlier, but I'll do it again just to see if this is my meter, my little tester being bad. Okay, this is a 47 microfarad 250 volt capacitor, and it's reading on the little meter at 45.18 microfarads with an ESR of 0.33. Let me try one of the 1000 microfarads, and when I read it, I get 1001 microfarads. So the tester is reading right. Those capacitors are just way out of spec. Okay, so all the capacitors have been replaced. Amazing how much smaller the new ones are than the old ones, but there they are, and there's the Zener diode we replaced. And if that doesn't do the job, we're going to actually be stuck for a while. So, bring up the motherboard. Have video hooked up. We have the speaker. We're going to plug in the power supply to the motherboard. And then the IEC connector. Make sure we're off. I'll do that one. And wish me luck. Do we get anything? Nope. Power supply still doesn't work. Okay, guys. Well, that's going to do it for this video. Stop the presses. Hold on. I got to thinking that there's a fuse in here and I should test the fuse. So I came back and checked. The fuse was not the issue. The fuse was just fine. It turns out what we had is we have a bad or a flaky connection in the power jack on this power supply. It's in the jack. It's in the plug itself, not the jack, because the jack works just fine with the Pico RC power supply. But we had a flaky connection on the 12 volts. Once I did a little tweaking inside that jack, we've got a good connection. And now, if you'll watch, we should get the beep and the screen. And there we go. All right, we've repaired the power supply. Now, whether it was the Zener diode or whether it was the caps, my bet is on the caps in this case. The diodes don't tend to go bad, but it was possible. But those caps were registering way too high capacitance reading. 1.6, 1.7 times the number of microfarads that they were rated for. So my bet is that the Re-capped fixed that. And we're good to go now with the power supply. So that will finish the video for today. I'd like to thank you all for watching. If you enjoyed yourselves, give the video a like. If not, you know what to do there too. If you're not already a subscriber, go ahead and click the subscribe button. You can also click on the little bell, and that'll give you options for getting notifications when I post new videos. I know that hasn't been very often lately, but I'm working on improving that. Share the video out to as many people as you like. Leave me comments in the comment section below. I'm hoping that that you guys might give me some direction as to what's going on with Adrian's dead test ROM. Again, I have reached out to him, but he's a busy fellow, so I don't know how quickly I'll get a response. The next video, I think, will be going to the keyboard. Again, I'm not looking forward to that. All those little leaf springs that have to be aligned just so. That's not going to be a great deal of fun to do, but it is necessary unless I can just find another keyboard. My Patreon supporters, your names are showing up on the screen right now. I appreciate everything you do. If you too would like to support the channel, you can do so on Patreon. You can also click the join button down below the screen here, and join the YouTube channel, or you can support me on Ko-Fi. If you'd like to donate something to the channel other than money, you can reach out to me and we can make arrangements for that. I would appreciate that. Let's see. Links to the things that I've used in this video are going to show up on the screen here in a moment. You'll see a link to the Pico RC website and a link to the very excellent Apple II Circuit Description, a book by W. Gaylor. A couple of the images that I've shown have been out of that book, but it is an incredible resource for learning about how the Apple II works. And as I've said, I have a long way to go to learn all of that. I think that'll do it. Now, this video is going to be released just before Christmas, 2023. That's why all the Christmas imagery in the beginning section of the video. So, for those of you who celebrate Christmas, have a Merry Christmas. For those of you who celebrate in other ways, enjoy your holiday seasons and stay safe traveling and stay healthy. And I wish you all a Merry Christmas and a Happy New Year. And we'll see you in the next video. Thanks for watching. Bye.